we'll discuss motion of variable mass system, rocket equation. Right. The first condition that we have seen in Newton's laws is that mass should remain constant. So the second law of Newton says the rate of change of momentum is proportional to the force applied. Otherwise, this force is equal to dV by dt. But here we are considering mass to be a constant and we are bringing it outside. So here mass is a constant, so we can take it outside of the differentiation. So that is why F is equal to ma. So the statement says the rate of change of momentum is proportional to force. The additional condition imposed there is mass also a constant. So this is the valid form of Newton's second law. So now comes the question how to apply this law to rocket equation, where the mass is changing continuously in the form of fuel consumption. Right. So then in that kind of situations we have to consider the total mass of rocket and fuel as constant. For that purpose I am considering rocket plus fuel with mass m and initial velocity or whatever velocity v. At some point its velocity is v. So m is mass of rocket plus fuel. V is the velocity. So now after some time, after our next moment, a small mass dm is ejected out of it and the remaining mass is m minus dm. Now let's say this is travelling with a velocity of v relative with respect to the rocket. So the actual velocity is v minus v relative. Let's say this is travelling at a speed of 100 kmph, other one is travelling at a speed of 80 kmph. Some mass is pushed out of it. So for the person sitting on the rocket, the velocity is 20 kmph backwards, velocity of dm. But for the outside observer, the velocity is 80, which is 100 minus 20. So the velocity of ejected mass is v minus v relative for the outside observer, and for the observer on the rocket, the velocity of ejected mass is minus v relative. It is moving backwards. So now, what is the velocity of the rocket? So some mass is pushed out of it. So there will be a reaction. So the velocity of the rocket also increases. So will it be v plus v relative? Do we get same rise in speed for the rocket also? It may not be same because the ejected mass is smaller compared to the total mass of the rocket. So the rocket will not get the same speed, the same rise in speed, but it could be some number. I call it as dv. So instead of v relative, I am placing dv, which is a smaller number compared to v relative. Okay. So now I want to calculate the change in momentum of this system. Okay. So now initial momentum is mv. Final momentum is what? Mass and velocity of these terms. So m minus dm times v plus dv plus dm times v minus v. That is the final momentum. So here we have 2 by 2, total 4 terms will come here, and 2 by 1, 2 terms. Total 6 terms will come in the PF and 1 term in PI. So what you get? MV plus MdV minus DMV minus DMdV plus DMV minus DMV relative. So these are the 6 terms, and out of that maybe this term will get cancelled, and if you take the difference of the momentums Pf minus Pi, these terms will get cancelled. So in total 4 terms got cancelled out of 7. 4, and I am neglecting this term dm and dv product, because dm is already a small number, dv is also a small number. So when you multiply smaller and smaller numbers, you will get even smaller number. So I am neglecting that. So I will be left with 2 terms. So mdv minus dmv relative. So this is my change in momentum. So now I can apply this. So what is that? F external is equal to dv by dt, which is m dv by dt minus v relative times dm by dt. So v relative is a negative number, okay. So in total, if dm is negative, I mean here dm is a change in mass. So I am assuming dm is negative. So the equation becomes f external is equal to m dv by dt plus v relative times dm by dt, provided dm is negative. If dm is assumed to be negative, the equation is that f external is equal to m dv by dt plus v relative dm by dt. Okay, and for rocket, this f external is equal to minus gt. There is a downward pull by the gravity. So the total equation now becomes m dv by dt minus gt is equal to m dv by dt plus v relative dm by dt. Otherwise m dv by dt is equal to minus gt minus v relative dm by dt. Yeah, so f external is minus mg. Which is a mass times gravity of the rocket acting downwards. Okay. So now I want to get the final velocity of the rocket and final height reached by the rocket. So I need to integrate this, right? So from this I try to get the value of dv. So I have to take out that dt and m. So this becomes minus g dt minus v relative 1 by m dm. So I have to divide with m and multiply with dt, the above equation. So dv is minus g dt minus v relative 1 by m dm. So now I try to integrate this. Let's say v0 is my initial velocity and v is the final velocity, and g dt time starts from 0 and ends at t, let's say, minus v relative 1 by m dm m naught to m. So if you integrate this, what do you get? So v naught to v minus gt 0 to t minus v relative 1 by m की integration log m naught to m. So v minus v0 is equal to t minus 0 g times minus v relative ln m minus ln m naught. So v is equal to v0 times minus v relative log m by m naught. So v is equal to v0 times v relative v0 plus v relative log m naught by m. So whatever sign we take, you should get that. I mean, if you start with, dm is negative. If you keep, if you don't change this sign, somewhere you should get a negative sign here at the end. But ultimate aim is this m naught is larger compared to m. So to ensure that, I am considering dm to be negative. Okay, so this is the final velocity of the rocket, and if you want to know the final height reached by the rocket, you have to integrate it further over time. So that becomes v naught t, and integral log x is x log x minus x. So this becomes plus v relative times m naught log m naught minus m naught minus v relative times m log m minus m. Minus gt is also there. So minus gt if integrate, minus 1 by gt square. So now I try to analyze this equation. So for that we need to know what is the sign of this resultant, m naught log m naught minus m naught, m log m minus m. What is the result of that? Is it a positive quantity or negative quantity? That should be decided first. Okay, so for that I am drawing a graph. Let's say if you take x log x log x graph will look like this. And if you take x, initially up to 1, x log x is negative. Because log x is a number less than 1. For x less than 1, log x is less than 1. Okay, so what are you doing? You are calculating x log x minus x. Let's say x is 0.5. You are multiplying with a number less than 1. So 0.5 times another 0.5, or even if it is 0.9, the product is less than x. So you will get a negative number for x values less than 1. So what I am doing there, I am multiplying with x on both sides. So x log x is less than x. So x log x minus x is less than 0. So I get a negative number, and it may be around 10. So after 10, so for x greater than x log x takes dominance. What is that? ln x is greater than 1. Log x value will be greater than 1. Eppudu x greater than 10. It is 10 power 1. I mean, so okay, log 10 and log 10 base 10, sorry, log 10 base 10 is equal to 1, and beyond that the value is greater than 1. So if it is base e, you have to consider the value of e. ln x will be greater than e. What is the value of e? It is around 2.03 or something, 2.30 or somewhere. Okay, so I'm giving this example for base 10. So when x is equal to 10, log x value will be 1. When x is equal to 10, log x base 10 value will be 1. And beyond that, then only it will cross the value of 1. Okay, I mean you have to make relevant modifications for base e. I mean just for understanding, I am taking base 10. So when x is equal to 10, log x base 10 will be 1. Beyond that only the log x value will rise beyond 1. So then ln x is greater than 1 for x greater than 10. So if I multiply both sides x ln x will be greater than x for x greater than 10. So this is the turning point. So beyond that, this term will take dominance. So I am considering only this portion where x log x takes dominance. So what do you get? X log x minus x. So this is a positive number. This is also a positive number. So I am generating two positive numbers and I am subtracting them. And so what is the result? Will it be positive or negative? So it depends on the values of m naught and m. So here m naught is greater than m. So this subtraction, when you subtract, the result is positive. You got a bigger positive number related to m naught and a smaller positive number related to m. So when you subtract, you get a positive number. So in total, the contribution from V relative is a positive number. V naught t is a positive number and minus half gt square is a negative number. So this number is increasing quickly as time increases. So here it is t square and all other terms you have only t. So in total, if your initial velocity and whatever relative velocity that is coming from exhaust mass is contributing positive to the velocity or positive to the displacement, and gravity is contributing negative to the final height of the rocket. So which one takes dominance decides whether the rocket falls down into sea or ocean or will it reach the sky. So if the positive terms take dominance, the final velocity is positive. If the negative term, gravitational term takes dominance, the final height is negative. Okay, and here actually this g value changes with height. So to be precise, we have to consider minus half g m by r square, where m is mass of earth and r square is height of the rocket from center of the earth. This term should be replaced with half gm r square t square, gm r square. So then this contribution also will reduce as you go higher and higher. So you have to take balance of all these equations, and ultimately if that maximum height reached by the rocket is positive, it goes up, otherwise it will fall down. So then comes the question, who will decide that V relative? Who will decide that? It is the velocity of the exhaust mass with respect to the rocket. So this velocity is decided by the thrust produced by the fuel. So if the fuel produces a high amount of thrust in a short span of time, that V relative will be higher. Otherwise it will be lower. So it depends on quality of the fuel that you are using. I mean the energy density of the fuel or heat capacity of the fuel. Right? So with that, I'm closing the session.